Here we're going to continue our work with the normal distribution and the empirical rule to take a look at some examples. So I've copied the normal distribution from above along with all of the different percentages that we calculated in the last video. So here in our example, suppose that SAT scores are nearly normally distributed with a mean of 1,500 and a standard deviation of 300. So that's going to be really important for us. Our mean is equal to 1,500 and our standard deviation is going to be 300. Before I look at any of the parts of this problem, I'm going to take this curve that I've created, this normal distribution, and I'm going to label all of these different points on my x-axis using the mean and the standard deviation that were provided to me in the problem. And this is going to make the rest of our problem a whole heck of a lot easier, because then we'll have this picture that we can reference for any of the questions that we might need to talk about this. So I know, let me erase this so we have a fresh starting point. The mean sits right in the middle. So my mean was 1,500, so 1,500 lives right here in the middle. And if I wanted to move, let's say, to the left, every time I take a step to the left, I'm subtracting my standard deviation. So I'm going to be subtracting, in this case, 300. So 1,500 minus 300, if I subtract those two numbers, I should end up with 1,200. If I want to subtract 300 again, I would end up with 900. If I subtract 300 one more time, I end up with 600. So every time I take a step to the left, I'm subtracting that standard deviation, which in this case was 300. Similarly, as I move to the right, instead of subtracting, the only difference is, well, I'm going to add my standard deviation, so I'll be adding 300. So 1,500 plus 300 should give me 1,800. Oops, 1,800. 1,800, I'm going to add another plus 300. That should give me 2,100. And then one more time, adding a final 300 right here should give me 2,400. And what this allows me to do now is, hopefully in this problem, if we're dealing with the empirical rule, all of the numbers that we're going to see should appear on my x-axis right here, and I've got everything neatly labeled, which means if I want to find a particular area, I have these percentages that I calculated in the last video. All I'm going to have to do is a little bit of addition. I'm going to have to think about what part of the curve am I talking about, and then add the corresponding percentages. So let's hop into part A, the first part. So in this case, it says, find the probability that a random student scores between 1,200 and 2,100. So we're looking between 1,200 and 2,100. So here's 1,200. Here's 2,100. I am looking at this portion of my normal distribution. Now, the percentages that we calculated in the last video are particularly handy because this isn't just within one standard deviation or two standard deviations or three standard deviations. In this case, I actually have this part right here is within one standard deviation. Oops, this part right here. And then I've got like this little extra bit right here. So I'd have to kind of get creative with how I did this problem if I didn't have these percentages already here. But what I can do now is I can just say, well, I'm going to take 34 plus 34 plus 13.5, and that covers the entire area between 1,200 and 2,100. So my answer for this problem, 34 plus 34 plus 13.5, and let me grab my calculator so I don't make a silly mistake. 13.5 gives me 81.5% of my data. In this case, we're talking about probability, so okay, if we wanted to convert that to a probability, I know that would be 0.815, but we can give the percentage here too, since that's what we kind of established our normal curve with. And that's it. I just have a little bit of addition to do. So that's why this curve in this drawing is so handy, because I can look at it, I can think about, okay, what part of my curve am I talking about, and then just do a little bit of addition. Let's take a look at another problem down here. So let's look at part B. Part B says, find the probability that a random student scores lower than 900. So here in this case, we only have one number to deal with. we're thinking about lower than 900 right here. So I want to think about, okay, what part of my curve am I talking about? Well, if I scroll back up, here's 900. Here's the area that I'm talking about. Let's use yellow. There's the curve that I'm talking about. And I want to talk about the scores that are less than 900. So that would mean these areas over here to the left. So I must be talking about this portion of my curve. So I'm really only talking about two numbers in this case. I'm talking about 0.15%, 0.15% and 2.35%. So I'm just adding those two numbers, and that'll tell me my percentage or my probability here. So 0.15% plus 2.35% should give me 2.5%, 2.5%, or again, if I want to convert that to a probability, that would be 0.025. So again, this picture really saved us because it took what seems like a pretty complicated problem and just says, okay, well, we just have a little bit of addition to use once you figure out the part of the curve. And that's why I always take a second just to highlight or think about the part of the curve. Draw it on there so that you can see for yourself. Let's take a look at one more part. Last part, part C here. Find the probability that a random student scores higher than 1800. So again, we're talking about higher than 1800. I'm going to scroll back up and look at my picture. Here is 1800 right here. So I'm talking about that particular score, and if we scored higher than 1800, well, we would be talking about the area to the right on my normal distribution. I would be talking about this section of my normal curve. So I'm going to take 13.5 plus 2.35 plus 0.15. So to finish this problem up, 13.5 plus, I already forgot, 2.35. 35 plus 0.15. Again, I'm going to grab my calculator here. 13.5 plus 2.35 plus 0.15 gives me 16%, or if we wanted a percent, or excuse me, a probability, that would be 0.16. So the empirical rule makes these types of problems really, really nice as long as you have this picture here. So take a second just to draw out this picture. Now, the empirical rule is extremely helpful, and it's a good starting point for the normal distribution. We are going to start to run into some problems, though, if we wanted to talk about a data value that doesn't live on our x-axis. So we had all these different x values, but what if I wanted to talk about like 1300 right here? How would I deal with